In this video, I'm going to show you how to extract lots of channels using LSD Topo Tools. In the previous video, I extracted this single channel using a lat long of a channel source, but this time I'm going to get all the channels. So if you remember from last time, we start with, so if you're in Linux or Windows, you start a terminal window. In Linux and Mac, you start a terminal window. In Windows, you start a PowerShell window, and then you run the Docker container. So here we are in the Docker container. You can go into LSD Topo Tools 2 and run a setup script. LSDTT2 setup. I've done this before, so it's very fast. You can just make sure that the code is working, so the programs are there, if you can get it to do that. Now I'm going to go into the data directory. If you'll remember, I had that in a data directory SB for Santa Barbara. And now we're going to run an analysis by changing the driver file. So this was the old driver file. So it looked like this. I messed this up actually, because this should be right Hillshade. So I can get rid of this, and all it's going to do is write a Hillshade. So let's do that. Oops. LSDTT SB.driver. Okay, so now there's the Hillshade. Ta-da! Okay, so the next bit is to try and get loads of channels. If you go into this list of things for extracting channels, so what you want is this thing, print chi data maps. So this is going to print the channels, and it'll have a bunch of extra information. One of them is the chi coordinate. If you're not familiar with this, you can ignore the next few seconds, but if you know what a chi coordinate is, you need some settings, so you can change the settings on this, so like the threshold area, and this is a concavity of the channels, but if you want, you just leave those at defaults. The other thing that this does is it has a bunch of little routines to select basins. So it wants a complete basin. It doesn't like basins that are cut off by the edge of the raster. You need to tell it what the threshold contributing pixels are for how big of a channel starts flow. There are more complex channel head finding algorithms, but we're just going to do this really rudimentary one. Then you have a minimum basin size and a maximum basin size. So I'm going to set this to some low number and to some big number. Okay, so let's plug all that stuff into the driver file. So where's our driver? Here's our driver. So we've already written the Hillshade, don't need to do that again. So first of all, you want the threshold contributing pixels. The default is 1,000. This is a pretty low resolution map, so I'm just going to do 100 for that. Minimum basin size, let's do something pretty small. Maximum basin size, the default is 500,000. Well, let's see. We can put 1 million here. And then we want this print chi data maps. True. I also don't want to bother with that text import in QGIS, so I'm going to do a different thing here, which is to print a JSON, GeoJSON. So hopefully QGIS will just ingest that. So let's save it. Run this again. Okay, so that was pretty fast. Go back to QGIS, and we now have this GeoJSON. So let's see what it looks like. So lots and lots of little channels. There's no channels up here because these run into the edge of the DEM. So basically it won't take channels that run into the edge of the DEM. These basins are too small. So you can do things like if you want to color by, properties, change the marker, get rid of the outline, make these a bit smaller. Let's do a, no, I don't want single. Let's do graduated. What do we want the column? So actually, this has lots of different things. It's got flow distance, elevation, drainage area, chi, for example, the latitude, longitude, all this stuff. So the basin keys and the source keys tell you separate these out by basins and things. So we could color it by chi if we wanted. And oops, I need to classify that. So this is a way to get a full map of all your channels. Again, this gets spit out as CSV data. So if I look at the data, there's the data. You can open it in Excel, and this is all the channel data. So you can make profiles with this. The different profiles, the different channels have different basin keys for different basins, and different source keys for the source headwater numbers. So each one of these particular channels will have a different source number in which you can interrogate. So each point will have, let's do a table. If I zoom in, each point will have a different source key, a different basin key.